The promise and the stars in the dark vacuum beyond our world. Countless rocky bodies drift in silence. They are remnants of the early solar system, untouched for over 4.5 billion years. But inside them lies treasure, rare metals, critical minerals, and even the fuel that could launch us deeper into the cosmos. Some asteroids are worth more than the GDP of every nation on Earth combined. For decades, this idea was science fiction, but today, it is inching toward reality. Yet, in 2025, asteroid mining remains a dream on the launch pad. No company has extracted and sold asteroid material. No refinery or robotic miner has returned payloads to Earth for profit. But the race has begun, and the stakes are enormous. This is the story of asteroid mining, where we are today, the challenges ahead, the companies taking the gamble, and the future that could change everything. The early missions before commercial ambition entered the picture. Asteroid exploration was the domain of national space agencies. The first major breakthrough came from Japan. In 2005, the Japan Aerospace Exploration Agency (JAXA) launched Hayabusa, an audacious mission to asteroid E. The spacecraft faced technical malfunctions, fuel leaks, and communication blackouts. But in 2010, it limped home, delivering mere micrograms of dust from the asteroid's surface, a historic first. This was followed by Hayabusa 2, targeting the asteroid Ryugu. In 2020, it returned over 5 grams of pristine material, enough to keep scientists busy for decades. NASA took its shot with OSIRIS-REx in 2016. The mission traveled over 200 million miles to reach the near-Earth asteroid Bennu. In October 2020, its robotic arm descended, touched the surface for just 6 seconds, and collected an astonishing 121 grams of regolith. It returned to Earth in September 2023, marking the largest asteroid sample recovery in history. These were science missions, not mining expeditions, but they proved the essential point: we can reach, touch, and bring back pieces of asteroids. Where we stand in 2025, the next leap is commercialization, and that's where the real struggle begins. California-based AstroForge is making headlines. Founded in 2022, the company aims to mine platinum group metals, rare and incredibly valuable on Earth. In April 2023, AstroForge launched Broca 1, a small satellite mission to test space-based refining technology in low Earth orbit. In early 2025, it sent Odin, a CubeSat designed to rendezvous with a targeted asteroid. Both faced setbacks. Broca 1's data link failed, and Odin's deployment ran into communication issues. But AstroForge says these are stepping stones, not failures. In Europe, the UK's Asteroid Mining Corporation is developing prospecting spacecraft. The Netherlands' Carmen Plus focuses on capturing small near-Earth asteroids for detailed study. In the US, Transastra is building optical mining systems using concentrated sunlight to extract water from asteroid regolith. Meanwhile, China is preparing its own big move. The Tianwen mission, launching in May 2025, will attempt to double target, visiting the near-Earth asteroid Como Oelewa in 2026, returning samples by 2027, and deploying a separate probe to Comet 311P Pan-STARRS. It's not a mining mission, but the engineering lessons will directly feed into future commercial efforts. The technology gap. The core problem is simple. Mining in space is nothing like mining on Earth. First, there's the rendezvous challenge. An asteroid may be moving at 50,000 kilometers per hour relative to Earth. Navigating to it requires precise orbital mechanics, years of planning, and flawless execution. Then comes the extraction problem. There's no gravity to hold material in place. Drill too hard and the regolith floats away. Some companies are experimenting with anchoring harpoons and nets. Others plan to completely enclose the target in a capture bag before breaking it apart. Finally, refining in microgravity is an unsolved puzzle. Melting metal in space requires extreme temperature control, and traditional smelting won't work without convection. Concepts include laser vaporization, microwave heating, and even magnetic separation of metallic particles. Among the most valuable resources isn't a metal at all, it's water ice. Found in certain carbon-rich asteroids, water can be split into hydrogen and oxygen to make rocket fuel. In-space refueling could slash the cost of deep space missions. The companies in the race. The modern asteroid mining race has clear frontiers. AstroForge focused on MTP asteroids for platinum group metals. Long-term plan refining metals entirely in space before returning them to Earth. Carmen Plus, Netherlands-based, aims to develop asteroid capture and water extraction capabilities. Asteroid Mining Corporation, UK firm, building small, prospecting satellites and mining robotics. Transastra, US company, developing optical mining, concentrating sunlight to vaporize ice and extract volatiles. These companies follow in the footsteps of early pioneers who didn't survive. Planetary Resources and Deep Space Industries were the poster children of asteroid mining in the early 2010s. Both collapsed under the weight of cost, risk, and long timelines. Their failure showed that space mining isn't just about engineering, it's about patient investors and careful economics. In parallel, national programs are paving the way. China's Tianwen 2, NASA's planned Psyche mission to a metal-rich asteroid, and Japan's future Hayabusa missions will all add to the body of knowledge. The economics of the space gold rush. Asteroid mining is often portrayed as an instant ticket to unimaginable wealth. The truth is more complex. Yes, a single platinum-rich asteroid could, on paper, hold trillions of dollars in value. But markets don't stand still. Dumping large quantities of platinum onto Earth could crash prices overnight, making the venture less profitable. That's why most experts believe early asteroid mining will focus on in-space resource utilization, ISRU, rather than flooding Earth markets. Instead of selling platinum to jewelers, companies could use asteroid metals to 3D print spacecraft parts in orbit. Instead of bottling water for sale on Earth, they could convert asteroid ice into rocket propellant and sell it to other space operators. According to market forecasts, asteroid mining could be a multi-billion-dollar industry by the 2030s, but its real economic power will come from enabling space infrastructure, satellites that never need to launch with full fuel tanks, Mars missions that refill along the way, and massive orbital habitats built from off-world materials. The law above the Earth: who owns space? The answer is complicated. The 1967 Outer Space Treaty, signed by over 100 nations, says no country can claim sovereignty over celestial bodies, but it doesn't forbid resource extraction. This legal gray zone is where modern policy lives. In 2015, the US passed the Commercial Space Launch Competitiveness Act, granting American companies the right to own what they extract from asteroids and other celestial bodies. Luxembourg followed in 2017, positioning itself as a global hub for space mining firms. The United Arab Emirates has also passed similar legislation. The Artemis Accords, signed by more than 30 nations, reinforced this approach, recognizing space resource rights under international law. But not everyone agrees. Russia and China argue this creates a de facto land grab, preferring a United Nations-led framework to manage resource rights. Until there's a universally accepted system, asteroid mining companies operate in a legal landscape that's still under construction. The future, 2030, 2040, 2050, what could the next 25 years look like? By the early 2030s, expect the first pilot mining missions: robotic craft, extracting small amounts of water, ice or metals, refining them in orbit, and selling to in-space customers. NASA's Psyche mission will provide deep insight into metal-rich asteroid composition. China, Europe, and private companies will all run testbed missions. By the 2040s, asteroid mining could scale up to full industrial operations. Orbiting refineries will produce fuel for lunar and Mars missions. Space-based manufacturing plants will 3D print habitats and spacecraft using asteroid metals. Large-scale solar power stations, built entirely from off-world materials, could beam clean energy to Earth. By 2050, asteroid mining may no longer be mining as we think of it, but an integrated part of a space economy worth trillions. Some economists predict the world's first trillionaires will be asteroid miners. Others see it as the foundation for permanent human settlement beyond Earth. The gold rush of the 21st century won't be in the hills, it will be in the stars.